All right. What up, everybody? How's it going? We're just gonna go over a couple of things here as review. We've done this before, but you do have a test coming up, and I want to make sure that you understand and you didn't forget how to do this stuff. All right. So let's check it out. I'm gonna give you three examples of common base exponent equations, um, and each one is gonna be a little different, and they're gonna go from easy to medium to quote unquote difficult, although I don't think it's too difficult. But let's check it out here. So example number one, um, I want to find out the value of x for all of these, right? X value. Right? I want to find the x value in all these situations. And if the problem was as easy as 2x plus 7 equals to x minus 1, that's just a normal equation that you guys have done 100 times, right? I'm going to make the same exact situation, but instead of just having it as equations, what if it was as exponents, meaning like this? Check it out. So let's say we have 2 to the power of 2x plus 7 equals to 2 to the power of x minus 1. Now in this situation, because the bases are the same, you know it's all about that base, so you have no troubles. Um, if the bases are the same, guess what? Then the exponents are also equal to each other, and you no longer need to worry about the bases. Okay, it's like as though they're not there. So you drop it like it's hot, and you just go ahead and solve it like you would any other equation, right? So in this case, I would say, subtract x on both sides, and that gives me x plus 7 equals to negative 1. I'm going to go ahead and subtract 7. X equals to negative 8, right? Again, bases are the same, so then that means that the exponents are equal, okay? Now, we will never give you a problem where the bases are not the same and expect you to, for example, let's say that this was a 3 instead, and be like, all right, how do you find the x value? That's much more difficult. We wouldn't ask you for such situation, all right? But having said that, we will give you a situation where it might look like this, where the bases are not the same, right? They're not the same, but they can be converted. Here's what I mean by that. So this is example number 2. Okay. All right, so example number 2. Let's say that we have 8 to the power of x minus 1, and I have 2 to the power of x plus 2. Now, initially you're thinking, wait a second, Mr. C. The 8 and the 2 are not the same base, so I can't just x minus 1 equals to x plus 2. I can't do that. That don't work. They're not equal to each other, right? Because the bases don't equal. Ah, but what if this base can be transformed into the exact same value, but with a base 2? You're thinking, how do I do that? How do I make them both be the second base? How do I turn that? Well, then in your mind, you got to know to some degree some of your exponents. So you're thinking, okay, I know that this is a 2, so this must be a 2 with a certain exponent. So 2 to the first is 2, 2 to the second is 4, and 2 to the third is 8. Aha. So I can change this 8 into a 2 to the third power. I can do that, right? I can just change it to base 2. And then I go ahead and bring down that x minus 1, right? So I've changed nothing. This is an 8. This is an 8. The only thing that I changed was the way in which I write that 8. Now, from here on out, since the bases are the same, I can go ahead and make the equations equal to each other. But check it out. You see that 3 right there? That 3 is going to be on the outside. And then that x plus 2 is right there. All right. So all that means is that I have to eventually distribute this 3 before I solve the equation. 3x minus 3 equals to x plus 2. Now, I'm pretty sure you can handle that, so I'm not leave that to you. I just wanted to show you how you transform uh, an expression that has different bases to be the common base. All right. Now, that's if you have, so I showed you one where you don't have to do anything to the bases, right? The bases are already equal. You have to change one of the bases, but in some situations, you might have to change both bases. So check it out here. So let's say that you have something like example number 3. Oh, sorry, example number 3. There you go. Example number 3 has you looking at 27 to the 5x power equals to 81 to the 3x plus 4 power. Right? Then you're thinking, whoa, this looks pretty complicated. But hopefully you can see, what base could I work 27 and 81 into? So hopefully you know your 3 tables and you're thinking, they both look like they're divisible by 3. So I'm going to try 3. 3 to the first power is 3. 3 to the second power is 9. 3 to the third power is 27. And I can change that to a base 3. Let's see if I can change it to a base 3 as well. 3 to the fourth is 81. So you see how both of these can be changed into a base 3. So I can change this into a 3 to the third, and I can change the 81 to 3 to the fourth, right? And change those. And then I have the 5x here, and I have the 3x plus 4 here. And all I have to do is, now that the bases are the same, I can go ahead and get rid of those bases, and I have 3, 5x, and I have 4 exponents. So I'm just dealing with the exponents now. 3x plus 4. And from there, go ahead and just distribute. You end up with 15x equals to 12x plus 16. And I think you can handle the rest on your own, but I just wanted to show you, right? So for this section, if you're not very comfortable with this, changing the base of the expression that we have, if you're not sure how to do that, I suggest you create a little mental cheat sheet, right? So on all your problems, both in your homework and in your test, we're not gonna make the bases too big. So you just have to know your 2's, right? Maybe your 3's, maybe your 4's, but when you look at the 4's, I wouldn't go beyond, 4 to the second power, and then 4 to the third power. Yeah, I wouldn't go beyond that. And same thing with the 5. Matter of fact, 5, I would just go with 5 to the first power, 5 to the second power, and 5 to the third power, and that's it. I wouldn't go any further than that. I would doubt that you would need to know any beyond this. So on your own, go ahead and fill this chart out, and just, if you don't have it mentally already, I would suggest you fill this out and then get familiar with them. So when you do have to find the basis, or change the basis, then you can convert it easily and just have this as a reference, right? Okay. If you have any questions, again, our teachers have office hours and come back at us. We can give you different examples if you run into issues. All right. All right. Peace out. Hang in there. Late.